Hey everyone, my name is Robert Ridahall. I'm a technical audio specialist with the Advanced Technology Group at Xbox. And in this session today, we are going to be talking about the Microsoft 3D Spatial Sound platform and integrating it into your games through our major middleware partners. The agenda for this session is pretty simple. We'll talk about integration into middleware such as Audiokinetics Wise, as well as Firelight's FMOD Studio. And then we're going to take a look at some best practices for you as you look at putting spatial sound into your game. So the Microsoft Spatial Sound system has a number of different offerings in terms of how sound can play back. We have two types of spatial object rendering. One is what we call channel-based fixed location objects. These are objects that represent home theater speaker locations. We also have what are called dynamic objects. These are objects that have a true position in space. And so we'll show how the middleware usage of these objects look like. And then we'll also talk about how you can do hybrid usage of both spatial sound as well as what we call 2D direct-to-ears sound. So maybe you want to have your music playback in your game right to the ears in a more traditional sense and have all of your sound effects virtualized over headphones. So we'll talk about that as well. So we have full support across all the various middleware for the Spatial Sound platform. This is done through plugins and syncs in the various middlewares. We're going to look at, as I mentioned, Wise, as well as FMOD Studio, and the different capabilities that each of these have. So first we'll look at FMOD Studio, and just a reminder, make sure that you're listening to this session over headphones, because what you will be hearing is the spatially rendered aspects in the playback as I demonstrate things here.
In FMOD Studio, it's extremely easy to get started with the Microsoft Spatial Sound platform. First, you go to your Edit menu and select Preferences. On the Audio tab, look at the output device and select the Windows Sonic output. What this does is changes the underlying system to now be writing to a spatial audio client, which sets up your master audio bus to run at a 12-channel 714 configuration. This configuration channels are running to what we call static bed objects. These are objects that have a fixed position in space that represent the idealized locations of speakers in a home theater system. In this case, 714 refers to the 7 speakers around you, your low frequency effect, and 4 height channels, 2 in the front and 2 in the rear. The engine then is able to pan to those 12 channels or playback multi-channel files to those as well. Here I'm going to show you a quick example of playing a full 714 wave file to the master output, so you can see and hear this playing in spatial sound. Take a listen to this. If you're on headphones, you should hear this fully virtualized all around you. The thunder above you, the raindrops externalized and around you. A nice, fully immersive experience. And with the master bus running at 12 channels, any sound effects that are panned will have the ability to pan to all of those channels, including the height channels. So that's the master bus output. What FMOD also allows for is what we call dynamic objects. Unlike static bed objects, the dynamic objects are sounds that have a true position in space. And while this doesn't really matter over speakers, because when a dynamic object is sent to an AVR, it's going to get channel panned to the speaker configuration by the AVR. Over headphones, the headphone renderer is going to place that sound exactly where it was located, instead of being placed and panned to virtual speakers over headphones. Now, there's some caveats to dynamic objects. For the spatial sound system, when you send audio to the system, it gets consumed at that point. You can no longer bring it back, loop it back into your system. So with dynamic objects, you have to think about how you're going to use these. If you're going to do any processing on them, that processing has to happen before you send it off to the system, because once it's gone to the system, it's been consumed and mixed at the system level. So to demonstrate this, first I'm going to show you a normal 3D panned sound. Just a simple white noise that I'm going to pan around in channels. You can hear it moving around. And if I bring up the mixer, you can see that it's been panned into the master output bus. To use a dynamic object in FMOD Studio, we use what's called an object 3D panner. And in this case, I'll play the same sound. The 3D object spatializer will have a position that sound is been given by the audio engine, and it will play. So you can hear it. But if I go now to the mixer, you'll see I'm not getting any sound out of our master bus, which means that sound is being sent off to a dynamic object, consumed by the system, and mixed and played by the system itself, not out the master audio bus in the FMOD engine. So those are the basics of setting up Microsoft Spatial Sound in FMOD. Super easy to get started.
So that's FMOD Studio. You can see we have the ability to play both channel-based 12-channel sounds as well as true dynamic objects. Now let's take a look at how the spatial sound system is integrated into Audiokinetic's WISE.
In WISE, version 2019 and earlier, it is very simple to get set up with the Microsoft Spatial Sound platform. To start, you simply go to your master audio bus, choose General Settings. Under Audio Device, select from the drop-down the Microsoft Spatial Sound Platform output. So now what this has done, similar to FMOD Studio, it has set the underlying engine to write a 12-channel 714 configuration through the master audio bus to the system. So I'll play you a couple of examples to show this in action. The first sample will simply be a channel ID playback, left, right, center. And what you should hear if you're listening over headphones is those channel IDs, those speakers being virtualized, externalized in your head, from your head. So here's channel IDs.
Left, right, center. Left side surround, right side surround. Left surround. Right surround. Height left front. Height right front. Height left surround. Height right surround.
So there you go. You should have heard those sounds externalized, played as though they're coming out virtual speakers over your headphones. One thing you may have noticed is that the LFE channel is actually played, which you do not get in a regular stereo fold-down mix to headphone. Now let's listen to that in full context. Similar how we did in FMOD Studio, we'll play our rain and thunder over 12 channels. Again, you can hear the thunder above you, the raindrops externalized and all around you. Giving you that nice immersive experience over headphones in this case. Now, WISE 2019 and earlier does not give us the ability to play back dynamic objects like FMOD Studio does, but it does give us the option to be able to do simultaneous virtualized and non-virtualized direct-to-ears sounds when listening to headphones. And this is simply done by using two master buses. To do this, I'll add a new audio bus. I'll call this my 2D master. And you'll notice under audio device, it defaults to system. And what this is doing is writing to the Wasapi output. Anything sent to Wasapi will play non-virtualized over headphones. So you can do things like play music direct to ears while you have all of your sound effects virtualized over your headphone output. And so that's how you can set up for the Microsoft Spatial Sound platform in WISE 2019 and earlier. We'll now take a look at the new features of WISE 2021 that gives us a lot more flexibility for using the spatial platform. In WISE 2021, Audiokinetic has introduced a whole new object-based busing system and changed how the final audio master device playback works. So it's actually become a simpler effort to use the Microsoft Spatial Sound platform in this version of WISE. You can see here we have our master audio bus. It is using the system device. The system device is looking at what the user has set for their output. And if the user has chosen a spatial rendering device, it will automatically set up for a main mix of 714 12 channel configuration, the ability to do pass-through to non-virtualized sounds over headphones, and to use true dynamic object playback, where if the renderer has dynamic objects available, it will use those objects. So I'll turn up the audio on something that's playing right now. Again, we have our rain going in the background, but now we have some lovely jungle birds playing. And you can see I have the jungle birds coming through as an object. So the exact location of those sounds is being played back as a dynamic object over the spatial platform. And the rainstorm is being played as a static bed of 714 channel configuration. And just to show you a little bit about how this works to do virtualized and non-virtualized sounds as well, I'm going to change the bird sounds to not use audio objects, but to use the pass-through mix. And now if I go back and look at my master audio device, my birds are coming through my 2D stereo mix. They're being appropriately panned based on their position, but they're now going through Wasapi and not being virtualized over headphones. So with WISE 2021, a lot more flexibility for spatial usage with dynamic objects, virtualized and non-virtualized sounds, and mixing of static channel-based sounds as well, all in one endpoint that is basically automatic. And that's how WISE 2021 and Microsoft Spatial Sound platform looks.
Okay, so now you've seen how the Microsoft Spatial Sound platform gets integrated into both WISE and FMOD Studio. Hopefully that gives you an idea of how easy it is to get things set up. Let's now talk about some best practices around the usage of spatial sound in games. These are just a sort of a top 10 list of practices that we have found over the years of watching games implement on the platform that really should keep in mind as you're looking at spatial. So with any major feature of any kind, I always like to say start in pre-production. We've had so many developers try to drop in features such as spatial sound platform during production or late in the game development. And a lot of times those features get dropped because there wasn't enough time to see all the consequences of bringing a new feature into the game. So start in pre-production. As much as you can, it will make your life a lot easier as you're basically working with spatial sound from the beginning of your project. You know, I talked a little bit about dynamic objects and objects, how they get consumed into the platform, and how you have to think about possibly doing your processing ahead of time because of that aspect. Is once that object goes to the system, you no longer have control over it. So this is especially relevant to DSP usage. For example, say I had sounds of radio chatter from different players. One traditional way I might do the radio DSPing on them is to collect all those voices into a single bus, do the processing once on that bus, and let them go. But now if I'm trying to use dynamic objects, I will need to put that radio DSP onto each one of those individual sounds before sending it off. So I might end up using a lot more DSP. Other things to consider when moving to spatial with DSP is, you know, we're all used to now doing mixing in 7.1. So a lot of our DSP, whether it's reverb or filtering, is working on, say, at most 8 channels at once. But with spatial, you are using potentially a 12-channel output, and now you have 50% more channels that potentially need that DSP. So just considerations in terms of how much processing you might have to do with your DSP for your game when moving to spatial. Careful use of dynamic objects. Again, just remember that not only are you having to think about your DSP usage and how the dynamic objects get consumed, but there's also a limited number of these objects. So you have to make sure that you're thinking about effectively scene managing the use of those. Dynamic objects are wonderful for giving that pinpoint accurate positioning, especially over headphones of sounds. But you might want to consider using them for more hero sounds. Do listen to all the render endpoints, making sure that because the user has a choice of how they want to listen to your game, they are really in control of how the sound is going to come out. So you, as an audio director or designer or developer, need to be aware that that is possible, that your sound is going to be coming out all sorts of different device endpoints, whether that be stereo TV speakers, headphone rendered, HRTF spatial rendering, or maybe a full Dolby Atmos home theater setup. Just be sure to make sure that you understand that your mix is working in all those endpoints. You want to also make sure that you're on the latest XDK or GDK for console and really understand the Windows ecosystem when it comes to development. And the reason I mention this is because with any feature, there's going to be bugs, and in the process of bringing up a feature like spatial sound and continuing to evolve it and develop it, bugs get fixed. So if you're on the latest GDK, you're guaranteed that you'll have all of the fixes that have gone in previously to the system. With Windows, it's a little bit different. You have to understand that while on the console, the system gets updated on a monthly cadence. With Windows, it's very different. At best, we're getting audio fixes in on major updates of Windows, and that happens regularly about every 6 months. So I like to always tell developers, when you're getting feedback from users and they're saying, I have a bug with the audio in my game, the best thing to do, the first thing you do is ask, what version of Windows are you running on? So you have some context under which to know where in the development cycle of spatial platform on Windows they are at. So low frequency content usage. This is something that we've learned not only from Dolby Atmos mixers and game development that we've done, is low frequency content does not localize very well. I mean, it's by its very nature, it's spread out. Low frequency sounds just sort of consume the energy all around you. So if you're wanting to have sounds that are particularly localizable, like you want a sound that's really sounds like it's coming from a height channel, make sure that you think about how the frequency of that sound is going to behave. If it's a higher frequency sound, your ears will naturally be able to pinpoint that sound. Listener orientation is another big one that we've learned. We had a title that had to drop spatial implementation because we put it in mid-development. But by that time, they had already had all of their systems in place, how the listener was moving through the world. And in this case, we had the listener was oriented between the camera and the character on the screen, as well as it was oriented kind of down. So what was happening is that sounds that looked like they were right in front of the character were actually being heard by the listener above. And so when the playback of the sound happened, those sounds were coming sort of unnaturally out of the height channels. Just again, another thing to think about and reason why you would want to start with spatial in pre-production so that you can accommodate these kinds of things. Duplication of content in heights is also another lesson learned. One of the things that happens, especially over headphones, is that you're if you're working with channel-based static bed objects, you're getting virtual speakers over headphones. And if you have the same content virtually rendered in, say, your rear channels and your height rears, they tend to interfere not very nicely together. And so you get kind of a phasey effect with that. If you're going to use height information, make it unique. Now, cutscene audio is an area where we know that a lot of cutscenes today are done in-engine, so you don't necessarily have to worry about this. But we have had titles where you have this wonderful experience of full spatial in-game running, and then a cutscene would come in, and the audio for that cutscene was in stereo. So you get this effect of going from spatial down to stereo and back to spatial as you go in and out of the cutscene. That's just kind of a jarring experience. If you're going to use pre-rendered cutscene audio, let's make it 12-channel. Make it a spatial experience so it's a lot more seamless. And finally, one of the things about spatial sound rendering is that it opens up the amount of space that you have for your mix. So take advantage of this. You have more room to play with. You're over headphones, you're no longer crunching your entire audio experience down to 2 speakers. You're actually externalizing and making all this room. So if you take advantage of that, spatial will give you a nice open experience with the playback. So where can you experience Microsoft 3D Spatial Sound? Here's some links and references. Microsoft has documentation and samples. I highly recommend looking at Dolby's support resources. DTS is also a partner on the platform, so take a look at them. Each of them also has the app. You can try out their renderers. And I also highly recommend attending some of the other audio sessions here at GameStack Live. We have a session on enhanced audio with spatial, as well as what we call a next-gen immersive audio session. And in those sessions, we will give a lot deeper details about the spatial platform. So I hope you all learned how easy it can be to implement spatial sound into your games through middleware, learned a little bit about the best practices about using spatial sound. And so I want to thank you for attending this session and enjoy the rest of GameStack Live.